Okay, before we get into anything real complicated, I want to show you what the spreadsheet commands are for using the t-distribution. This will be a pretty short video, just a couple of examples. We'll try a few, and then we'll do a much bigger example. So let me share my screen out to you. Okay, beautifully enough, the spreadsheet commands for the t-distribution are basically the same as what, I have a small mistake here. I'm going to fix it while I'm on video, because it's the mistake that we all make. That stupid little 1 there. All right. Okay, basically, the spreadsheet commands for the t-distribution are the same as they are for the normal distribution. T.dist asks for a test statistic, so the number of standard deviations that you are away from the mean. The degrees of freedom, which again, based on the previous slide, tells you about how fat the tails are. Remember, degrees of freedom is related to sample size, and then comma 1 to accumulate. And what this will do is find the probability of getting a test statistic less than t. So on the picture here, I feed it a t, and I feed it a degrees of freedom, which controls how fat the tails are and how tall the peak is, and it returns for me a probability. That is t.dist. T.inverse does this backwards. If I have the degrees of freedom, so again, the shape of the curve, basically, and the p, the probability, T.inverse will return for me the test statistic. So let's try a few. All right, and I'm going to take this out of full screen mode, and I'm going to put my slideshow right next to my spreadsheet here. Okay, so I want to find the portion of area to the left of t equals, let's see here, negative 1.30. All right, so let's do it like this. If I go t equals negative 1.30, and I want to go left, okay, and my degrees of freedom is 12. Okay, now with the degrees of freedom of 12, I've got a fairly wide tail here on the t-distribution. So this is t.dist because I want a probability out. That's a portion of the area. I have a t and a degrees of freedom. So negative 1.30 and degrees of freedom is 12. That means my sample size was 13, comma 1. And I get the area on the curve. So in this particular case, if I come back to this picture, my cutoff was somewhere down here. And I was looking at the blue area to the left of that region, so somewhere just over here. Okay, let's do another one. I want left of t equals negative 1.30, same t-score this time, with degrees of freedom equals 24. So now I've got more degrees of freedom, so the t-distribution should be squeezed tighter. Okay, well, let's check. T.dist of, okay, so I wanted a t-score of negative 1.3, degrees of freedom of 24. That's associated with a sample size of 25, comma 1. Now, before I press enter here, if I've squeezed my t-distribution tighter, stop and think. Should I be getting less area over on the left, or should I be getting more? Ooh, it's actually not a whole lot less, but it is less. It's just a smidge less there. I want to do one more with this. I'm going to go left of t equals negative 1.30, same t-score with degrees of freedom equals 2400, massive degrees of freedom. T.dist, negative 1.30, that's a test statistic. That's how many standard deviations your data is away from the mean. Comma, degrees of freedom is 2400, comma 1. All right, and it's actually less yet. So as the degrees of freedom goes up, the tails get pulled in and get smaller. Okay, let's do the next one. I want the portion of the area to the right of t equals 2.3 with degrees of freedom equals 10. Now, if I'm going to go to the right and the software only reads left, I need to do 1 minus whatever this area is. Because remember, the area under the whole curve is 1. All right, so it's 1 minus t.dist of, let's come back to this guy. Oops. All right, my t-score, my test statistic was 2.3, my degrees of freedom was 10, and of course I'm accumulating. Okay, and it's fairly small because we're a long ways from the center. 2.3 is quite a ways away. Okay, let's go the other way around. Oh wait, no, I'm sorry, I want to do one more. Right of t equals 2.30 with degrees of freedom much, much larger, let's say like 1,000, right, equals 1 minus, because I'm reading right, t dot dist, again, because I have a t-score and a degrees of freedom and I want a probability, t-score, degrees of freedom, accumulate, and it should be smaller because I'm reading the right-hand tail, and if I get more degrees of freedom, my tails get smaller. And sure enough, it's quite a bit smaller. Okay, now let's do these last two. I want the cutoffs for the middle 80% with degrees of freedom equals 15. Okay, now the middle 80% is the middle of your distribution. Well, let's see, 80% leaves 20% left over, so that's 10% on either tail. So my lower cutoff has 10% below that. All right, well, that's going to be, well, let's see here. I know there's 10% below. Let's go back to my commands here. I have a probability now. I have that 10%, and I have the degrees of freedom. It will give me the test statistic associated with that. So t dot inverse of 0.10, 10%. My degrees of freedom was 15. Enter. So there's my lower cutoff. My upper cutoff, well, let's see. Again, I've got 80% in the middle, 10% in the tails, and my upper cutoff is going to have the 80 plus the 10, so 90% below. So that will be t dot inverse of 0.9, comma 15. And I know that if I go between negative 1.34 and positive 1.34, I'm going to pick up 80% of that particular t distribution. And one last example here. Let's do the cutoffs for middle 95% with degrees of freedom equals 20. Okay, my lower cutoff, let's see here, 95% leaves 5% in the tails. That's 2.5% in each tail. So that would be 2.5% below this lower cutoff. So t dot inverse of 0.025 with 20 degrees of freedom. There's one cutoff. My upper cutoff is 95% in the middle, 2.5 in each tail. So I want the middle plus the left-hand tail. That's 97.5% below. So t dot inverse of 0.975, comma, my degrees of freedom. Okay, and now I know that between 2.08 negative and 2.08 positive, I've got 95% in the middle. Now recognize that this is a little bit different than a normal distribution. If I want the middle 95% on a normal distribution, it's usually like 1.96. But on a t distribution, the tails are actually a little bit fatter, so we're going to read a little bit wider in order to pick up the same amount of information. Okay, I hope at this point you have a good sense of how the t distribution works in a spreadsheet.